Today we're going to cover the WireMock Runner, a cloud-controlled, locally executed API simulation tool from WireMock Cloud. The API simulation challenge usually comes in a couple of forms. One is that mocking APIs that live behind corporate firewalls can be difficult with the built-in WireMock Cloud recorder from the fully hosted SaaS platform. And developers demand fast, responsive feedback loops and oftentimes prefer working with WireMock open source or standalone because of this. Additionally, WireMock Cloud SaaS, while it does work inside of CI/CD pipelines, those pipelines often run inside of secure local networks, and we want to minimize the calls to external APIs that live outside of those secure networks. So what teams have needed until now? They used local or open source WireMock because it had full control and speed. The latency was minimal. It was isolated from using the public internet, but it didn't have really good team collaboration features. And building those in themselves or having to scale WireMock open source for parallel runs or performance testing has been difficult. With the cloud solution, it has great collaboration features, a lot of advanced capabilities that open source doesn't have, but it required making calls to WireMock Cloud, which lived in US east of AWS, and oftentimes this introduced latency or broke security policies. So today we're introducing WireMock Runner. WireMock Runner can be deployed anywhere, whether that be local laptops, CI systems, Kubernetes clusters, you name it. It can be inside of your private networks. And we're calling this a hybrid-first architecture, where your mock APIs are managed and versioned and shared across teams for collaboration using the fully hosted SaaS platform, but you can get local execution and local recordings using WireMock Runner. So what's the architecture of WireMock Runner? Of course, we still have WireMock Cloud, which manages your configurations and versions and collaboration settings. But now we also have WireMock Runner, which runs inside of your private networks, either on a laptop or on a shared server or Kubernetes cluster. And the only piece that syncs between these two are the metadata. This metadata is the configuration set of what a mock API is, who has access to it, and what are the rules for responding to requests coming into it. So why does this all matter? Of course, there's security aspect where calls to mock APIs hosted in WireMock Runner never leave the private network. It's fully offline capable, meaning there's no need to have an internet connection after it comes online. There is reduced latency because we no longer have to transverse the public internet to hit the fully hosted SaaS version of WireMock Cloud. And you get consistency across environments because you can deploy these via CI/CD pipelines, check in your configurations next to your source code, and a whole host of other capabilities. So when would you use Runner? When you're behind firewalls, you'd use it in CI/CD pipelines, on developer laptops, in Git-based workflows. Completely air-gapped environments is a good use case for Runner. And the classic AI LLM testing is another use case for using Runner when you want to avoid hallucinations from your AI LLM endpoints. So WireMock Runner is really built for the developer workflows that are prevalent in today's environments. It can be configured as code, it's got version control integration, it's GitOps compatible, and it's microservices native. And the migration to using WireMock Runner from WireMock open source is very easy. So let's take a look at what the demo agenda is today. We're going to deploy Runner on a fresh Kubernetes cluster that I'll create using Kind on my Mac OS laptop. We'll then go ahead and record multiple APIs using the record many feature of WireMock Runner. And then we'll do a discussion on promoting mocks via Git and CI. So first we're going to deploy Runner on Kubernetes. We're going to be following the instructions in docs.wiremock.io found underneath the how-to guides in the Runner section and running on Kubernetes. Let's start to issue these commands. So the first one I'm going to do is I'm going to pull down the demo project from GitHub. We can see that that was done real quickly here. And then let's go ahead and change our Active Directory to that Kubernetes runner demo. At this point, we can make sure that our WireMock CLI is installed by doing a WireMock who am I. This is a prerequisite that the WireMock CLI is installed on the workstation. All right, we're good to go. We can see that I'm logged in as dan@wiremock.io. Now, following the directions, let's go ahead and issue the create cluster command. Creating the cluster will just take a few moments. Again, I'm using Kind on my Mac OS laptop in order to stand up a pretty basic, minimal developer style Kubernetes cluster. And we'll see that just takes a moment or two. Okay, now that this is created, we can move on with the rest of our instruction set. The next step is to run the set secret shell script, which will extract our WireMock Cloud API token from the WireMock CLI configuration set and store that as a secret in the Kubernetes cluster we just created. The next step is for us to run the install WireMock shell script. So let's go ahead and run the install WireMock shell script. We'll see that this is actually going to be the part that installs the WireMock runner into our Kind cluster using a Helm chart that comes along with the project we downloaded from Git. This process takes a little bit of time, maybe a minute or two. So let's wait and have it finished before we proceed. Okay, it's been about a minute or two and our script has been completed and we can see that WireMock Runner was deployed successfully. In order to verify this, we'll go ahead and run the next command in the guide, which tells us to run the kubectl or kubectl get pods for the app named WireMock-Runner. And we can see that indeed the WireMock Runner is up and running. Now let's come down a little bit further and test the APIs. I'm going to go ahead and copy another command from our how-to guide. I'll clear the screen here and let's issue this curl command. We're going to be going against the paypal.local.wiremock.cloud fully qualified domain name, which I've set in my local host file on my Mac laptop so that it resolves appropriately to localhost. And we can see that we are getting a response back from WireMock Runner for this API endpoint. Let's try one more. We'll curl against another mock API that's deployed automatically as part of this project. This one is the Git endpoint, and we're going to ask for /users. And again, we can see that WireMock Runner is now successfully serving a couple of mock APIs that were part of that configuration set. The next thing that we're going to demo is recording with the CLI. We've deployed our runner on Kubernetes. Let's go ahead and now demo recording multiple APIs. So we can see that we're going to position the runner, we're going to capture the traffic, we're going to generate the mocks, and then we're going to push them to WireMock Cloud. Now positioning the runner, we've already done that by deploying the runner to our Kubernetes cluster. So now let's switch over to capturing traffic. We're going to move on to the recording on Kubernetes how-to guide at this point. Now, the first thing we're going to do is we're going to set up a development environment using the WireMock CLI. We'll do that by doing WireMock environments, create, and then the -- profile command and call it development. This will just take a moment. We'll see that the CLI is creating the environment development. It created a mock API PayPal invoicing record with the target development, and it's successfully created an environment file. Now let's go ahead and push the existing stubs to WireMock Cloud. So we'll issue the WireMock push mock API, all mock APIs in the profile called development. Now we can see that these have successfully been pushed to WireMock Cloud. We can verify that in our browser. Let's go ahead and come into WireMock Cloud, and we'll see that as of today's date, 11/14, that we've pushed a PayPal invoicing record target and a GitHub REST record target with the environment variable or environment name called development. Now we need to set up the profile in the runner. This means modifying the configuration set of the runner to tell it what it should do in recording mode. So we're going to come back over into our command prompt window here. Let's go ahead and clear this again. And let's modify the WireMock runner.yaml file. Now, this is a Helm manifest file that tells the Helm deployment what to do. And following the instructions, we'll come down into the environment variable section. We can see down here in the containers, WireMock Runner, environment. We're going to go ahead and add 2 more environment variables as documented inside of the how-to guide. First one being name, WMC, run profile, and then we'll give it a value of development. That's that environment that we created earlier. And then we'll go with one more environment variable with the name of WMC, record, many, profile. And again, we'll reference that environment that we created earlier, develop. We'll save these changes, and then we have to go ahead and rerun our installation. This will just take a couple of moments for it to complete. We can see that the deployment has successfully completed at this point. Let's go ahead and use the API of WireMock Runner to switch it from the playback mode into the record many mode. So again, from our how-to guide, I'm simply copying a command. Let's go ahead and clear this. The command I'll be running is a simple curl. It's a put command where we're going to pass the mode of record many. That executed successfully. Now we're going to just start making requests to our endpoints, and they'll be recorded while the runner is in record mode. Again, from the how-to guide, I'm going to copy a command, and we're going to request from the real GitHub API that is now being recorded via our mock API in record many mode. We're going to ask for the organization's path. So we'll hit that. We'll see that we get a successful response coming back through the recorder. And after we've done that, we can continue with our instruction set, and we can flush the recorded traffic out of the recorder, the WireMock Runner record many. We always flush our recorded traffic before stopping the recorder or switching modes, because the runner does not automatically flush when we switch those modes. So any unflushed recordings would be lost. So we want to make sure we do this flush before we stop the recording and or switch modes. So I'm going to do that now. I'm going to go ahead and stop the recording by telling the WireMock Runner to switch from record many back to the serve mode, where it is no longer doing any recording. It's simply using the rule set in the mock APIs to compute the response to any requests coming into those mock APIs. We're now back at serve mode. Now let's go ahead and grab our WireMock Cloud mock API endpoint for the GitHub. So we can see that that is listed right here. I'm going to grab my base URL, and we can come back over and now issue a curl to our WireMock Cloud fully hosted SaaS version of the recorded endpoint. And let's ask for that organization's path. Now we can see we got a response back, and we can verify that that was actually served by WireMock Cloud by coming into our request log and see that just a few moments ago, a get for /organizations came in, and WireMock responded as such based off of the recording we just accomplished. Now the last step here is to pull these changes into our local development workstation. So right now we've done the recording, and we've pushed that recording into WireMock Cloud so that we can collaborate on it with other users. But now we want to sync all of our mock APIs in that development environment back to our local environment or into WireMock Runner. So let's go ahead and clear our screen here. Again, from the how-to guide, we're going to go ahead and issue this command. This is WireMock pull mock API, all from the profile development. So this will look for all of the mock APIs that are tagged as development in WireMock Cloud and pull them locally into my environment here. And at this point, we can go ahead and restart the WireMock Runner so that it picks up all of the most recent mock API changes that were just synced by that WireMock pull mock API all command. And as usual, this will just take a couple of moments to come up. Now that we're back up, let's go ahead and clear our screen, and we'll do one final test. Instead of going against the WireMock Cloud fully hosted SaaS version of the Mock API, we're now going to go against the one that is running in our cluster using WireMock Runner. You can see we're now getting those results back. We positioned the runner, we captured the traffic, we generated the mocks, and then we pushed them to cloud. And then we even pulled them back down into WireMock Runner. The typical end-to-end developer workflow for creating and maintaining mock APIs using WireMock Runner is we're going to record them locally, either using WireMock CLI or WireMock Runner. We can do that in record many mode, so we can record multiple APIs in parallel. We then push those to cloud so that they get uploaded to our WireMock Cloud environment. Then we can decide to share those with teams by sharing those mock APIs. We can check all of the local assets that are created using WireMock Runner or WireMock CLI into Git, so we can have versioning on top of those configuration sets, and allow our automated CI pipelines that deploy Runner automatically to update the mocks to the various different test environments, using those environment variables to package them nicely into multiple APIs. And then we can execute against them locally using WireMock Runner inside of our Kubernetes cluster. Or you can deploy it using Docker to any centralized server. It doesn't necessarily have to be Kubernetes either. So what are the key takeaways from this demonstration today? With WireMock Runner and WireMock CLI, you get the best of both worlds. You can deploy your mock APIs to the fully hosted SaaS and have them reachable to any environments that can communicate to the public internet. You also get all the additional collaboration and extended features that WireMock Cloud has to offer, including data sources and stateful mocking, chaos, just to name a few. You have enterprise-ready security when you run these with WireMock Runner because no traffic ever has to leave your private networks anymore. You get additional developer velocity where we can work completely in code to build, maintain, check in, deploy mock APIs. And it's a perfect complement to WireMock Cloud. If you're comfortable using WireMock Cloud fully hosted SaaS endpoints, continue to use them. Or you can use this hybrid approach where you can pull all of those assets down locally to a workstation or to a centralized private server and serve your mock APIs from there. I thank you for your time today. Please feel free to reach out to us with any questions you might have. We'd love to dive deeper with you. Thank you.